the solution of triangle contains the new point, the cosine rule. In that in triangle ABC, a square is equal to b square plus c square minus 2bc cos a, b square is equal to c square plus a square minus 2ca cos b, and c square is equal to a square plus b square minus 2ab cos c. Okay, in that we prove that first one, that a square is equal to b square plus c square minus 2bc cos a. For that we takes A is at standard position. That means if we draw the x-axis and y-axis, here is the origin of that x and y-axis, that it has the coordinates 0, 0. Therefore A has the coordinates 0, 0, and the side AB is along with positive x-axis. That as the distance of AB is C unit, coordinate of B is C, 0, and coordinate of CR, that the length or distance between origin and point C is B, and here is it makes angle A with positive x-axis. Therefore coordinates of C are B cos A, B sin A. Okay, using polar coordinate system, we get the coordinates of C, that are b cos A, b sin A, and coordinates of B are that C, 0. Okay, by distance formula, that length of BC is equal to square root of B cos A minus C bracket square plus B sin A minus 0 bracket square. Therefore that length of BC is equal to, that is square root of, we solve this square. Okay, therefore that is b square cos square A minus 2bc cos A plus c square plus b square sin square A. Okay, squaring on both sides, we get that length of BC bracket square is equal to b square cos square A. We interchange the terms here, therefore plus, here we write b square sin square A minus 2bc cos A plus c square. Okay, that length of BC, here the length of BC is A, therefore here we write length of BC square is A square. Therefore A square is equal to, in these two terms we take b square common. Therefore b square into bracket cos square A plus sin square A plus c square minus 2bc cos A as it is. Therefore A square is equal to, we know that is the identity, first trigonometric identity, cos square theta plus sin square theta is equal to 1. Therefore cos square A plus sin square theta, sin square A is 1. 1 into b square, that is b square plus c square minus 2bc cos A. In this way we prove the first rule, that a square is equal to b square plus c square minus 2bc cos A, by taking angle A is at standard position. If we take angle B is at standard position, we will prove the second theorem. And if we take C is at vertex C is at standard position, we can prove C square is equal to A square plus B square minus 2AB cos C. By similar process, we can prove these two theorems also. Now we go to prove the projection rule in triangle ABC, that A is equal to B cos C plus C cos B. That B is equal to C cos A plus A cos C. Then C is equal to A cos B plus B cos A. From this, we have to solve the first one. A is equal to B cos C plus C cos B. For that, we consider its RHS. That RHS is equal to B cos C plus C cos B. By using cosine rule, the first that cosine rule is A square is equal to B square plus C square minus 2BC cos A will give that cos A is equal to A square B square plus C square minus A square divided by 2BC. Okay. Similarly, B square is equal to C square plus A square minus 2CA cos B will give cos B is equal to C square plus A square minus B square divided by 2CA. And C square is equal to A square plus B square minus 2AB cos C. That will give cos C is equal to A square plus B square minus C square divided by 2AB. We substitute these values in that RHS. Therefore, RHS is equal to that B as it is into that cos C. Here we have the value of cos C, that is A square plus B square minus C square divided by 2AB, plus this C as it is into cos B. The cos value of cos B is C square plus A square minus B square divided by 2CA. Here we cancel this B with this denominator D and this C with this C. Therefore, here we get A square plus B square minus C square divided by 2A plus C square plus A square minus B square divided by 2A. Both the terms have denominators are same. Therefore, we add directly their numerators, that is A square plus B square minus C square plus C square plus A square minus B square, this divided by 2A. That plus C square minus C square get cancelled. Also that plus B square and minus B square get cancelled. Remaining only A square plus A square, that is 2A square divided by 2A. That 2 get cancelled and 1A of numerator cancels with this A. Therefore, here remaining only A, and that is our LHS. Similarly, if we take the second formula, that B is equal to C cos A plus A cos C, and put the values of cos A and cos C, okay, then in the similar manner here we can prove the second one and also the third one. In that way, we have learned the cosine rule and the projection rule. We saw some examples on cosine rule. That first one, in triangle ABC, if A is equal to 2, B is equal to 3 and C is equal to 4, then prove that the triangle is obtuse angled. Suppose I have drawn here triangle ABC. That's A, B, C. Therefore, this side is A. Okay, this is B length, and this side AB has length C. That A is equal to given 2 value, B is equal to given that value is 3, and C is equal to value given 4. Okay, then the largest side is that AB is the largest side. Here AB is the largest side, and we know that the opposite angle to the largest side is the largest angle. Therefore, angle C is the largest angle. Therefore, by cosine rule, C square is equal to A square plus B square minus 2AB cos C gives that value of ABC. Here we substitute that C square, that is 4 square, is equal to A square, that is 2 square, plus B square, that is 3 square, minus 2 into 2 into 3 into cos of C. Therefore, that 4 square is 16 is equal to 2 square 4 plus 3 square, that is 9, minus 2 into 2 4, 4 into 3, that is 12 cos C. Therefore, that 16 is equal to 13 minus 12 cos C. Therefore, that 16 minus 13 is equal to minus of 12 cos C. Therefore, that is minus 3 is equal to minus of 12 cos C. Therefore, plus 3 is equal to minus 12 cos C. Therefore, cos C is equal to 3 divided by minus 12, that 3 ones are 3 and 3 fours are 12, gives cos C is equal to minus 1 upon 4. That cos C is equal to minus 1 upon 4 shows that cos ratio of angle C is negative, shows that angle C is obtuse angle. Therefore, triangle ABC is the obtuse angled triangle. Okay, now we solve the one more example. In triangle ABC, if angle A is equal to 60 degree, B is equal to 3 and C is equal to 8, then find the value of A and also find the circumference of the triangle. Okay, that given that angle A is equal to 60 degree, angle A is equal to 60 degree, B is equal to 3 units and C is equal to 8. Therefore, by cosine rule, that A square is equal to B square plus C square minus 2BC cos A. Here we substitute the values, that B square is equal to 3 square plus C square means that is 8 square minus 2 into 3 into 8 into cos of 60 degree. That is equal to that 9 plus 64 minus 48 cos of 60 degree, that is 1/2. Therefore, A is equal to that 9 plus 64, that is 83, 73 minus that 2 ones are 2, 2 twos are 4 and 2 4 are 8 minus 24. Therefore, A is equal to, that is 9 4. That A square is equal to 49. Therefore, A is equal to 7. As the A is the length of side of BC. Okay, that is distance between the point B and C. It cannot be negative. Therefore, here we take only positive square root of the 49. Okay, now also here we have to find circumference of the triangle. For that we use the sine rule. By sine rule, that A divided by sine A is equal to 2R. That gives the value of A is 7 and sine A, that A is 60 degree, is equal to 2R. Therefore, 7 divided by sine of 60 degree, that is root 3 divided by 2 is equal to 2R. That is 14 divided by root 3 is equal to 2R. Therefore, that R is equal to 14 divided by root 3 into 1 by 2. That 2 1s are 2, 2 7s are 14. Therefore, here we get R is equal to 7 divided by root 3. Next example is, in triangle ABC, prove that A into bracket B cos C minus C cos B is equal to B square minus C square. Here we have to use the cosine rule. We know the cosine rule. B square is equal to C square plus A square minus 2CA cos B. That will give cos B is equal to cos B. We interchange the terms, that minus 2 CA cos B we will take in the left side, and that B square we will take at the right side, and after that 2 CA which is multiplied to cos B we take in the right side. It will divide the term. Therefore, cos B is equal to, that is C square plus A square minus B square divided by 2CA, and C square is equal to A square plus B square minus 2AB cos C implies that cos C is equal to A square plus B square minus C square divided by 2AB. Okay, for that, now to prove this one, we consider its LHS. That LHS is equal to A into bracket B cos C minus C cos B. Okay, now we multiply this A in bracket, that is AB cos C minus AC cos B. We substitute the values of cos C and cos B here. That is AB into bracket, that cos C is A square plus B square minus C square divided by 2AB, minus AC into bracket, the value of cos B is, that is C square plus A square minus B square divided by 2CA. Here that AC, that's AC cancels with AC, that AB will cancels with AB. Here remaining A square plus B square minus C square divided by 2 minus C square plus A square minus B square divided by 2. As the denominators of both the terms are same, we subtract their numerators directly. That is A square plus B square minus C square. There is a minus sign in between these two terms. Therefore, we interchange the signs of each term in the second. That is C square minus C square. That plus plus a square becomes minus a square, and that minus b square becomes that because of this minus sign it becomes plus b square. This divided by 2. Here that plus a square and this minus a square get cancelled, and remaining that plus b square, that is 2b square, and that minus c square, that is minus of 2c square divided by 2. Here we take 2 common in the numerator, that 2 into bracket b square minus c square divided by 2. That 2 get cancelled. Here remaining only b square minus c square. That is our RHS. Hence we proved the given theorem. Now one more proof is there, that is in triangle ABC prove that a plus b into cos c plus b plus c into cos a plus c plus a into cos b is equal to a plus b plus c. Now for that we consider its LHS, that is a plus b into cos c plus b plus c into cos a plus c plus a into cos b. We multiply these terms in the brackets. Therefore, it becomes a cos c plus b cos c plus b cos a plus c cos a plus that cos b is multiplied, each term of this bracket is c cos b plus a cos b. By using the projection rule, that is a cos c plus, we take in the bracket that c cos a. With a cos c, we take c cos a. Plus that b cos c, in the second bracket we take b cos c, and with this we take the term c cos b, and the remaining terms in the bracket, that is b cos a plus a cos b. By projection rule, that a cos c plus c cos a is the value of b, plus that b cos c plus c cos b, that is a, and plus that b cos a plus a cos b is c, that is a plus b plus c, and that is our RHS. Hence we proved that a plus b into cos c plus b plus c into cos a plus c plus a into cos b is equal to a plus b plus c. Next example, in triangle ABC, prove that a into cos c minus cos b is equal to 2 times of b minus c into cos square a upon 2. For this we use projection rule. We know the projection rule, that b is equal to a cos c plus c cos a. This will give that a cos c is equal to that b minus c cos a, and c is equal to a cos b plus b cos a. And this will give that a cos b is equal to c minus b cos a. Okay. Now we consider the LHS, that LHS is equal to a into bracket cos c minus cos b, that is a into cos c minus a into cos B. Using this, we substitute the values that A cos C is equal to B minus C cos A minus, we take this in the bracket that A cos B is equal to C minus B cos A. Now we solve these brackets. Here we get B minus C cos A minus C, and because of this minus sign, here changes the sign, plus B cos A. That we take that B minus C in the one bracket, and the remaining terms, that is plus B cos A minus C cos A. Here we take cos A common. Therefore, that B minus C plus, if we take that B minus C, that cos A common, therefore we write outside the bracket. Now here B minus C is common. Therefore here remaining bracket 1 plus cos A. And we know that by submultiple angle formula, that is 2 times of cos square A upon 2. This 2 is a scalar multiple. Therefore we write here that 2 into B minus C into cos square A upon 2, and that is our right hand side. Hence we proved that A into cos C minus cos B is equal to 2 times of B minus C into cos square into A upon 2. Now we solve that next theorem, that prove the cosine rule using projection rule. For that we write the projection rule. But the projection rule is as follows. That A is equal to B cos C plus C cos B. We say that is equation number 1. Then B is equal to C cos A plus A cos C. We say that is equation number 2. And C is equal to A cos B plus B cos A. We say that is equation number 3. If we multiply this equation by A square, multiply equation 1 by A. Here we get in the left hand side, that is A square is equal to, we multiply each term of the right hand side by A, that is A B cos C plus A C cos B. We multiply the second equation by B. That second equation into B gives B square. B square is equal to, we multiply B to each term of the right hand side. Therefore, that is BC cos A plus AB cos C. And multiply the third equation by C. That equation 3 into C gives that C square is equal to, multiply each term of the right hand side by C, that is AC cos B plus BC cos A. Okay, let us consider that A square plus B square minus C square, that is equal to that A square plus B square, that is AB cos C plus AC cos B plus that B square, that is BC cos A plus AB cos C. And here we take minus C square, therefore here write minus of AC cos B plus BC cos A. and we solve the right hand side. That we solve the brackets. That is AB cos C plus AC cos B plus BC cos A plus AB cos C minus AC cos B. That because of minus sign outside the bracket, we change the sign of this term. Therefore, it is minus of BC cos A. Therefore, that plus BC cos A, that minus BC cos A get cancelled, and that plus AC cos B and minus AC cos B get cancelled. Here remaining only AB cos C plus AB cos C, that is 2 times of AB cos C. Therefore, if we bring this term in the LHS and bring this minus C square in the right hand side, here we get A square plus B square minus 2AB cos C is equal to C square. That is, C square is equal to A square plus B square minus 2AB cos C, which is the cosine rule. Similarly, we can prove other two, that is A square is equal to B square plus C square minus 2BC cos A, and B square is equal to C square plus A square minus 2CA cos B also. Therefore, in that way, we have proved cosine rule using the projection rule. In this session, we have seen cosine rule, projection rule, and some examples on cosine and projection rule. In the next session, we will see application of sine rule, cosine rule, and projection rule. Thank you.